Professor van Huisteen, I have the honor to present to you Neil Jeffrey Turok with a request that you confer on him the degree Doctor of Science, honoris causa. The decision by Council and Senate to award him this degree has been taken on the grounds of the following considerations. Neil Jeffrey Turok is an original thinker and doer. His career as esteemed mathematical physicist and exceptional contribution to education and development attest to an innovative approach to long-standing questions, from the Big Bang to the advancement of science on his beloved African continent. Die gebore Johannesburger het sy opleiding aan Churchill College, Cambridge en Imperial College, Londen ontvang. Sy uitnemendheid word vinnig raak gesien. In 1994 word hy fisika professor aan die Universiteit van Princeton en 3 jaar later voorsteur van die wiskundige fisika aan die Universiteit van Cambridge. Turok verhuil Cambridge in 2008 vir Canada, waar hy as direkteur van die toonaangewende Perimeter Instituut vir Teoretiese Fisika dien. Hy is boonop buitengewone professor in fisika aan die Stellenbosch Universiteit en dien as besoekende genoot van die Stellenbosch Instituut vir Gevorderde Navorsing, STIAS. Professor Turok's significant and award-winning work as mathematical physicist includes the by now confirmed predictions about the correlation between polarization and temperature anisotropies of cosmic background radiation and the design of a key test for Einstein's cosmological constant. Along with Cambridge colleague Stephen Hawking, he developed the Hawking-Turok instanton solutions for the birth of inflationary universes. Turok's collaboration with Paul Steinhardt on cyclic model for cosmology resulted in the book Endless Universe, in which he describes a model relating to the Big Bang for a more general readership as part of his continuous pursuit to unlock science for all. However, for this son of Africa, the advancement of science and the continent remains a priority. In this respect also, his distinctive commitment and ingenuity proved a winning combination and led to the establishment of the African Institute for Mathematical Sciences, AIMS. This postgraduate training center in Muizenberg presents various mathematical science courses focusing primarily on African students. Due to an innovative approach to inter-university collaboration, AIMS is about to expand across Africa. The quality of their training makes AIMS students sought after and opens the door to further studies locally and abroad. Dames en here, in 2008 ontvang Turok die prestigeryke TED-prys vir sy rol as kosmoloog en onderwysaktivis. Hy benut die platform om 'n wens uit te spreek dat die volgende Einstein vanuit Afrika sal kom. Vandag is die Next Einstein projek 'n TED-ondersteunde inisiatief wat fasiliteite en geleenthede skep om aldus Turok briljante mense van Afrika in die wetenskap te laat uitblink. Professor van Huisteen, I request Stellenbosch University to hereby honor Neil Turok, himself a brilliant person from Africa, for his excellent contribution as physicist and cosmologist and his continued efforts as education activist to unlock the world of science for fellow Africans.
I hereby confer on you, Neil Jeffrey Turok, the degree Doctor of Science, honoris causa.
George Steyn, Chairman of Council, Professor Leopold van Huisteen, Acting Vice-Chancellor, Professor Christo Viljoen, the Chairman of the Convocation, and all our honoured guests, our 3 new honorary doctorates, and of course all our other doctorates. It is a great pleasure for me to be here today and to propose a toast on Neil Turok. A special word of welcome to his mom and dad who are here, Mary and Ben, for taking time out to join us to celebrate this occasion. Now, Neil was born in Johannesburg, and his parents were imprisoned for resisting the apartheid government at the time. And upon their release, they had to move to Kenya as refugees, and this is where Neil went to primary school. So when it got time to go to high school, they moved to London. He was not so excited about that. I get the feeling that Kenya was far more excitement than London. But nevertheless, he continued there, and then he completed his degrees and decided to come back to Africa. And he volunteered as a teacher in Lesotho. And then I think something profound happened. Now, he refers to himself from time to time as someone who has a schizophrenic career. And I'm going to tell you two stories which I think influenced that way of thinking. The first was when he was a teacher in Lesotho, he used to take the children out of classroom to show them physics in nature. And he posed a problem to his class, and he said to them, how would you estimate the height of a particular building that was in sight there? And then something unexpected happened. One of the young kids went down, sat down, and started to make calculations in the soil. And Neil was a bit surprised about this, asking them, what are you doing? You're not even looking at the building. And he said, no, I did have a look at the building, and I counted the layers of bricks, and I found a brick, and I've measured that, so I'm busy calculating the height of that building. Now that made him, of course, realize the brilliance of people in Africa. By the way, Dr. Turok, I used that same technique to calculate that the lecture theatre where we had the graduation ceremony in this morning is about 12.5 meters high. So that made him, and you will realize why I tell you the story, because it had a profound influence on what he did later on in his life. The second had as a profound influence. So he studied the Big Bang Theory with an ever-expanding universe, and he met up at some point early in his career with one of his teachers, a Scottish lady, and he was trying to explain to her in simple terms what this Big Bang Theory was about. And after he explained it to her, she asked him, "Will Neil tell me what banged?" Now, of course, that is quite a good question because the influence that had on his future thinking is profound. Because out of that, he went back and he started to study the Big Bang Theory in a totally different way. And he came up with what is now well known, together with Stephen Hawking, as the unified universe theory, which is now one of the most accepted theories of the origins of the universe in the world. Now, the interesting thing is that, and perhaps you could try to explain in brief terms what that amounts to, but the essence of that is that we might, in fact, well, first of all, that the Big Bang was not the singularity event, but it happened in already existing universe. And perhaps as we speak, many Big Bangs are happening. And I will stop there and leave it to Neil to explain further. Well, all of this time, one thing remained in his mind, and that is this concern about Africa. And when he visited his parents on a holiday, he kept on thinking about what Africa needed to become successful. Because over many years, many things have failed in Africa, and he was really concerned about the economic, low economic growth, war, disease, children dying as a result of commonly preventable diseases, etc., etc. Of course, in order to get out of this situation, you need education. And you need, in his words, and I agree with this, physicists, mathematicians, and scientists. Eventually, democracy arrived in South Africa, and both his parents were elected to Parliament. They were the only couple in Parliament, excepting the Mandela family at the time. So, I've known Neil for a few years, and there's one thing that has struck me about Neil, and every time that I've heard him speak, I've heard these words, and that is a visionary person, but with a plan, because to have vision without a plan is daydreaming. But he's someone with a vision and a plan. So his idea was setting up an African Institute for Mathematical Sciences. Now, I wondered about the name and why he chose that name, because at the time he could have used the Cambridge Institute for Mathematical Sciences because he was at Cambridge, or perhaps the Perimeter, or the Canadian, but he chose the word African Institute for Mathematical Sciences, and I think that was deliberate. He was a Cambridge professor at the time. He went back. His immediate thoughts would be that he would be violently opposed to this idea, but they in fact bought into the idea. And that started the African Institute for Mathematical Sciences, or as we know it, AIMS. It's a network between centers of excellence to teach special math and science curriculum and expand AIMS across the continent. He partnered with 3 universities, with the University of Cape Town, with the University of the Western Cape, and with the University of Stellenbosch. So it's a virtual university that he built in a real physical space in Muizenberg, in an old hotel that was purchased, and they refurbished this into a university where the students and their professors stay. And lecturers come from all over the world, most of them on a voluntary basis, some of the best lecturers in the world to teach the students maths at this institute. In 2010, the Canadian government funded a $20 million expansion of the AIMS model, working with the Perimeter Institute to start 5 new AIMS schools in different African nations. The second AIMS program was launched in Abuja in Nigeria in July 2008, and last month AIMS Senegal welcomed its first class. In the next 2 years, AIMS anticipates the addition of 2 new centers in Ghana and Ethiopia. By 2013, all 5 centers will be fully operating. To 2016, all 5 centers will be fully operating, and the world will be on its way to meeting its first African Einstein. Accepting his 2008 TED Prize, physicist Neil Turok speaks out for talented young Africans measuring bricks to estimate the height of buildings, starved of opportunity. But unlocking and nurturing the continent's creative potential, we can create a change in Africa's future. He then starts with a wish and a plan. His wish is that the next Einstein would be African, and that thousands of Africans would be inspired and motivated to improve their education. His plan is to build on an already proven model of AIMS, and the plan is to establish 15 similar centers around Africa. Centers must be relevant, innovative, cost-effective, and of high quality. AIMS alumni now make up 450 students, with over 30% women. Graduates hold positions in education, research, and industry. AIMS has established a secretariat in Cape Town and opened 2 centers for postgraduate training and research. They also hold 2 chairs by the Department of Science and Technology. One is connected to the Square Kilometre Array, which will be the largest radio telescope worldwide. But Neil is currently the director of the Perimeter Institute in Canada, which began as a bold idea to strategically invest in one of the most fundamental fields of all science. The vision was radical, yet simple. Build an environment to help foster the breakthroughs that will transform our future while sharing the power of physics with the world. They believe, and so do I, that breakthroughs are realized through a collision of intellect, imagination, and inspiration. Remember when you were little, how you'd spend hours exploring a stream or taking apart a flashlight. perimeter researchers never stopped playing or asking questions. That's what made them one of the world leaders in physics. To know science is not a series of facts, but the ever-changing way of understanding our universe. A student once told Einstein, when he had to write his exam paper, he said, "Dr. Einstein, but this is exactly the same paper that we had last year." And Dr. Einstein said, "Yes, this is true, but the answers have changed." I'd like to end by sharing Neil's wish, and I quote, "My wish is that you help us unlock and nurture scientific talent across Africa so that within our lifetimes we are celebrating an African Einstein. The question, however, is, how would we recognize the next Einstein?" Neil, who knows? Perhaps one day you may be recognized as one of Africa's own Einsteins. I now request you to raise your glasses to toast to Neil Turok.
It's really a very happy occasion to be here at Stellenbosch. My interactions with the university go back to 2001, and I will tell a story, about the first time I came to Stellenbosch. It was a Sunday morning, and your then rector, Chris Brink, invited me to come and meet him at 11 a.m. on a Sunday morning, because that was the only time we could meet. And I was in a suit and a tie, because I was trying to impress him, and he was in a tracksuit. And it was his birthday. But he took time out to meet me, and he said, I understand you want to start a maths institute for the whole of Africa. And I said, yes. And he said, that's exactly what I wanted to do, because he's also a mathematician. And he said, more or less immediately, we commit our full support. Stellenbosch will give you all kinds of services to help you get the institute going. And ever since then, our relationship with Stellenbosch has been very special. The first director, fortunately, Stellenbosch insisted on his retirement when he reached 60. And it was our win. Very foolish policy, by the way. But we benefited very strongly. When he retired from Stellenbosch, he became the first director of Ames. And he built the institute in Muizenberg, which established a world reputation. Fritz Hahner. The second interaction I had, the second rector of Stellenbosch who supported Ames, was, of course, our beloved Russell Barton. And, we were worried that when the mathematician left at the head of Stellenbosch, maybe Stellenbosch would become less interested in Ames. And would a theologian have any interest in a mathematical center? And we couldn't have been more wrong, because Russell, if anything, was even more enthusiastic about Ames, and he lent his even stronger support and became a trustee for Ames itself. And we met last night as the trustees, and we sorely miss Russell. Absolutely exceptional human being. And then the second director of Ames, Barry Green, was head of mathematical science at Stellenbosch, and again we stole him away, and he's doing a fantastic job running the Ames Center. And I have to correct a few pieces of information. It's not surprising. Ames is developing so quickly that almost daily there are new developments. We have 5 centers now: South Africa, Senegal, Ghana, Cameroon, Tanzania. There are 220 students currently doing postgraduate degrees at Ames centers. We just looked at the applications this year, last night. We have 2,600 applicants, all postgraduates. As my father pointed out, 400 of them already have masters, but they're coming to Ames to raise their level to international standard, to the highest level, and across all fields, because maths is everywhere. Most people don't realize this, but what controls your electricity? It's people doing modeling and mathematics. You know, what controls your cell phones, your computers, the transport systems, health. How do we monitor health, distribution of medicine, water? All of these things require skills, technical skills, and those are essentially come down to mathematics. What is physics, after all? It's just mathematics applied to the real world. That's all it is. If I often say if financial mathematics worked, it would be called physics. But what do I know about business? I want to talk about physics because my two passions in life, as has been mentioned, and I thought Dr. Madansela put it so eloquently, that oddballs change the world. And we must appreciate oddballs. There's nothing wrong with being an oddball. My first oddball experience was when my parents were put in prison. And I was 3 when my dad was taken away for 3.5 years. And that was the most profound educational experience in my life. Because what I saw is somebody totally committed to change, to a future that few others believed in at the time. And that influenced me very profoundly. It influenced me to be courageous and not to be afraid of standard wisdoms, which is exactly what you were saying. So I went into physics. Now, some people think physics might be absolutely objective, and I think you even implied that all you do is mess around in business. You know, we mess around in physics a lot more than you, because our messing around usually has no consequence. So it's a lot safer place to mess around. But physics is an example of the incredible capacities we as human beings have. That is why I do physics. We, through building on the discoveries of others, Newton and Maxwell and Einstein, and all of the great developments over hundreds of years, we are able to understand the whole universe. It's insane. I have personally written down and solved equations on a computer and gone to people who build satellites, which I call real people. I call people like myself imaginary people. Mathematicians among you would really get that joke, because there are numbers called real numbers and numbers called imaginary numbers, and together they make complex numbers, which are pretty wonderful things. Anyway, I'm strictly imaginary, but I need to go to real people because they do experiments and they test whether any of the ideas I discuss make any sense. So I went to satellite designers, the people who ultimately launched the Planck satellite, which launched a couple of years ago. And I said, you've got to measure the polarization of the microwave background, and I can tell you exactly what it's going to be using these equations. Now, to be honest, this is one of the least creative things I ever did, because these equations were well known. Nobody had really bothered to just work out the consequences. It was rather mundane, straightforward calculation. You turn the handle, and it tells you what is predicted. Nevertheless, nobody had bothered because measuring it was extremely challenging. You have to be able to measure the temperature of the sky to 1/10,000,000th of a degree Kelvin. Right? Now, 1 degree Kelvin is a very cold temperature, but 1/10,000,000th is extremely cold temperature. And it was at that time beyond the limits of technology. But it was on the horizon, and they worked very hard. 10 years later, we're now in the position where this is routine. And so they measured the predictions and the equations that I worked out and the predictions we made, in which there were really minimal assumptions, are verified to exquisite precision. So it turns out that the universe, the way I like to describe this is that the whole universe turns out to be simpler than an atom. It's insane, but the universe is comprehensible. We need one number to describe the structure of the universe on the very largest visible scale. That one number tells us the level of fluctuations which we see in the sky. Those fluctuations, we see them as they were a long time ago, 14 billion years ago, and they are what evolved into galaxies and stars and planets and ultimately people. So you need fewer numbers to describe the structure of the whole universe on large scales than you do to describe a single atom. It's an amazing fact, and I believe it's a very profound clue to the next revolution in physics. We are now on the threshold of such a revolution. We all know that the revolution in physics which happened in the beginning of the 20th century changed everything. That was a revolution which brought in relativity, E equals mc squared, nuclear power, GPS, all these things originated in relativity, and at the same time quantum theory, which was the foundation for all of modern electronics, lasers, PET scans, everything you undergo, all the advanced technologies in hospitals rely on those discoveries made at the beginning of the 20th century. That revolution, by the way, was wrought largely by people who had been excluded from science up to that point. Einstein was a Jew. Jews were not allowed to go to university in Europe to study technical fields until the middle of the 19th century. They'd been excluded. When the young Jews entered university for the first time, they had a point to prove. They were representatives of their people, and they wanted to disprove the notion that Jews simply had to be peddlers and moneylenders and all the traditional notions. And boy, did they disprove it. Okay, there was Einstein and Born and Niels Bohr, and over the course of the 20th century, their discoveries, young Jewish physicists, completely changed the world. So this revolution was wrought alongside and in part due to social transformation. Now, you don't have to be a genius to look at Africa and to see the potential for the same thing to happen. Physics has reached a point where those discoveries at the beginning of the 20th century, quantum mechanics and relativity, have to a large extent played out. We've found the Higgs boson. Again, the Higgs boson is 1 billion times smaller than an atom. Okay? It was predicted by pure mathematical reasoning in the 1960s. 50 years later, the greatest experiment ever constructed, the Large Hadron Collider, found the Higgs boson exactly where it was expected to be. The theory has played out, quantum mechanics and relativity, but there are massive puzzles which have not been resolved. We now know that empty space, the vacuum, is full of energy. When people talk about the energy crisis, it always amuses me because the whole universe is full of energy. The vacuum is full of energy, it's called the dark energy, and we don't know what it is. We have no idea what it is, but we know that 70% of the universe, the energy in the universe, is this dark energy. It's a huge, huge puzzle. But now we have data. We have the Planck satellite, we have the Large Hadron Collider. They are pointing the way to a new picture of physics. And the encouraging thing is the universe is much simpler than most of our theories expected. I have built all kinds of theories, very complicated, contrived, artificial theories. That's not what the data is pointing to. The data is pointing to extreme simplicity. At the same time, there are these huge unresolved questions. It's exactly the same situation physics was in at the beginning of the 20th century. And that's when the revolutions happened. I firmly believe the conditions are ripe for another revolution in physics. I believe the entry of new cultures into physics is essential to enable young people to tackle those most profound questions. And that's what AIMS is designed to do. We have been overwhelmed with the uptake of these advanced courses by young Africans. We've been impressed by their performance. They are now, some of the AIMS alumni are now world-leading scientists. One is a top specialist advising West African governments on how to handle Ebola. That's also mathematical. You need to make projections. You need to take data. You need to analyze the impact of the interventions made by governments. And our alumni are almost without exception employed in high-level scientific research or in industry or in government, and they're far exceeding anybody's expectations. So I think the next 10 years are going to be very exciting as we see science in Africa take off. I'm sure Stellenbosch and STIAS and all the other enterprises in this area are going to be a part of it. Africa has a very, very bright future, and I truly believe we will get to an African Einstein. So thank you very much.